Welcome back to the Deep Dive. We're here to guide you through today's most compelling info, all tailored for you. And today, okay, let's unpack this. We're diving into the really dynamic world of Java full stack development. Think of this not just as a list of things to learn, but more like a map designed to help you become a really proficient Java full stack dev. Our mission, pretty straightforward. We want to lay out the key skills, give you a clear roadmap, and share some practical advice, some real world wisdom. By the end, you should feel informed, definitely, but also ready to actually go and build things. So let's kick things off. What does it really mean today to be a Java full stack developer? What's the core idea?
The core idea, well, fundamentally, it's about being comfortable building applications end to end. That means you're not just stuck in the back end writing Java APIs with, say, Spring Boot. You also know how to build the front end, the part the user sees, maybe using Angular or React. And crucially, it also covers working with databases, knowing how they tick, and even handling deployments. It's that versatility, really, being comfortable across that whole range. That's the defining trait. You're seeing the whole picture.
I like that, seeing the whole picture. It's quite a scope, though, isn't it? From deep back-end logic to the user interface. Okay, so for someone maybe just starting out or even a developer wanting to expand their skills, what's the best way in? Where do you start?
Right. Starting from scratch. The best path really begins with mastering core Java. And I don't just mean syntax. You need to get OOP, object-oriented programming, how to model things. Plus, things like collections for handling data and multi-threading so your app can do multiple things at once. Once you feel solid there, then you move to Spring Boot. That's key for building REST APIs efficiently. After that, you can gradually bring in front-end frameworks like Angular or React. And databases, DevOps tools, they sort of naturally fit in as you start building actual small, complete projects.
Okay, so Java first, then Spring Boot, then branch out to the front end. That makes sense. But let's zoom in on the back end for a minute. That Java core. Can you detail that progression a bit more, step by step for the back end?
Absolutely. Think of it like climbing a ladder. You start with core Java, like we said, then you move to the broader Spring framework. Understand its core ideas, dependency injection, AOP. Then you hit Spring Boot, which makes Spring development way faster. Next step would be something like Hibernate and JPA for talking to databases effectively. With that solid base, building REST APIs becomes much more straightforward. Then you might explore microservices architecture, learn about security, and definitely, finally, wrap it all in good testing. Each step kind of builds on the last, preparing you for real-world stuff.
Spring Boot keeps popping up there.
Right.
Why is it so dominant? Why is it the king for Java backend right now?
Spring Boot. It's popular for good reason. It basically slashes boilerplate code, all that repetitive setup, gone. Plus, it gives you embedded servers, so you can just run your app, no need for a separate server install usually. And critically, it bundles in production-ready features, things like health checks, metrics. They're just there. It makes building things, especially microservices, incredibly fast and reliable. Companies love that speed.
Yeah, that speed and reliability, I can see why that's huge. Okay, so beyond the framework itself, like Spring Boot, what about design patterns? Are they crucial for back-end mastery?
Oh, absolutely crucial. Frameworks give you the tools. Patterns tell you how to use them wisely. You should definitely know patterns like singleton, factory, observer, builder, strategy. And the repository pattern is a big one. Think about the repository pattern. It's not just about hiding database details. It lets you potentially swap databases later without rewriting everything.
Right, like switching from MySQL to something else.
Exactly. Or even to NoSQL. It gives you that flexibility, that future-proofing. You see these patterns all the time in big enterprise systems. Knowing them is key for solid code.
That makes perfect sense. Okay, strong back-end foundation laid, but what about the front end? The user experience side. How important is that? Even if someone feels like, look, back-end is my thing, can you just dabble?
I'd say ignoring the front end is a mistake, even if back end is where you're strongest. Knowing a framework like Angular or React means you can build the whole solution. You understand the full user journey. You can see how a button click eventually leads to data being saved. That perspective is super valuable in teams. It helps you translate what the business wants into something real and usable.
Okay, so definitely not something to just skip over. But that learning curve, it can feel intimidating, right? Two whole ecosystems. How do you balance learning both without getting completely overwhelmed? Is there like a rule of thumb?
It definitely can feel like a lot, yeah. A personal rule I often suggest, and it seems to work well, is something like spend 60% of your learning time on the back end, then maybe 30% on the front end, and the remaining 10% on DevOps, tools, the cloud basics. It helps you build that strong backend base first, which is crucial for Java roles, then layer on the rest. Prevent spreading yourself too thin early on.
60-30-10. That's actually really practical advice. Okay, now the classic question, Angular or React? People always ask. Which one to pick first?
Ah, yes, the eternal debate. Look, both are fantastic. Angular is, let's say, more structured, more opinionated. It gives you a full toolkit. React is more of a library, lighter, more flexible. You often pull in other libraries to build a full app. Honestly, my advice is just pick one. Whichever seems more interesting or relevant to jobs you're seeing, master that one first, then later, if you need or want to, explore the other. Don't try learning both at the same time right at the start. It just slows you down.
Pick one. Dive deep. Got it. And how do you actually learn it effectively? Beyond tutorials, how do you make it stick?
Right. Tutorials only get you so far. The absolute key is hands-on practice. You have to build things. Start small. A to-do list app, a simple dashboard that pulls data from an API you built, maybe a basic storefront. Every time you build, you hit real problems. State management, handling errors, making things look right, that's where the real learning happens. It builds confidence.
Building projects. Okay.
Why?
What about the design side? UI, UX. Do full-stack devs need to be designers too?
Nah, not full-blown designers. But you do need a basic understanding of HTML, CSS, the fundamentals. Knowing about responsive design, making it look good on phones and desktops is important. And basic accessibility awareness. It just means you can build stuff that's functional, looks decent, and works for everyone, even if you're not a design guru.
So enough to be dangerous, basically. Or rather, enough to be effective.
Exactly. Enough to be effective and build professional-looking interfaces.
Okay. And thinking about interviews for full-stack roles, are there specific front-end skills that really stand out, things interviewers look for?
Yes, definitely. They'll often probe on your understanding of the component lifecycle in whatever framework you use. How you manage application state is huge, good error handling, how you integrate with backend APIs reliably, and increasingly, performance optimization. Can you make the front end fast and smooth? These show you can handle real-world complexity.
Right, the practical stuff. Which brings us to the bridge, doesn't it?
Yeah.
Connecting front-end and back-end. How do you master that integration? That seems like the core of full stack.
That is exactly it. That integration is the magic, and you master it through practice. Simple as that, but crucial. Build your REST APIs in Spring Boot. Then build your Angular or React app to consume those APIs. Every feature you build that needs data fetching it, displaying it, sending updates back reinforces that connection. That continuous loop of backend creation and front-end consumption, that's the bridge. That's what makes you a true full-stack developer.
Build the bridge by walking across it again and again. Makes sense. Okay, let's widen the lens a bit. Databases. Foundational. How do you really get good at database skills?
It's a layered approach again. Start with SQL. Gotta know SQL. Queries, joins, understanding indexes for speed, basic optimization. Then maybe get familiar with a specific database like MySQL or PostgreSQL. Understand its quirks. Once you're comfy with SQL, then look at ORM frameworks like Hibernate with JPA. Hibernate lets you work with Java objects instead of writing raw SQL all the time. It speeds things up, especially for complex apps, but you need that SQL foundation first to know what it's doing.
SQL first, then the tools like Hibernate. Got it. And the cloud. Is that a must-know now for full-stack devs?
Oh, yeah, definitely. It's pretty much expected now, at least the basics. You should understand core AWS services, for example, like EC2 for virtual servers, RDS for managed databases, S3 for storage, maybe even serverless stuff like Lambda. Knowing how to deploy your code where it lives, that's part of the job now. It's not just for the ops team anymore.
Right, deployment is part of development now. What about DevOps tools then? Which ones are essential for shipping code confidently?
Okay, essential tools. Git is non-negotiable. You absolutely need version control for teamwork. Jenkins, or something similar, for CI/CD automating builds and deployments. Huge time saver, reduces errors. Docker is massive. Containerizing your app so it runs the same everywhere. Solves so many headaches.
The works on my machine problem.
Exactly. Docker helps kill that excuse. And knowing Kubernetes basics is increasingly valuable for managing those containers. Then tools for quality, like SonarQube for checking code quality. And maybe logging monitoring tools like the ELK stack to see what your app is doing in production. These tools give you confidence. Confidence to ship, confidence to maintain.
That's quite the toolkit. And weaving through all of this, testing. How vital is testing?
Testing is, well, it's everything. It's non-negotiable, foundational. For the backend, you need JUnit and Mockito. Learn how to write unit tests, integration tests. For the front end, tools like Jest or Karma are standard for JavaScript testing.
Yeah.
Think about it deploying code without tests. It's like flying blind. You might get away with it once or twice, but eventually.
Yeah, disaster looms.
Right. Clean code is good, but tested code is what gives you and everyone else real confidence. It's proof your code does what you think it does.
Tested code inspires confidence. I like that. Okay, shifting gears slightly. As developers get more senior, how important is system design?
Oh, for senior roles, it's extremely important. Paramount, really. You need to understand scalability. How does this handle more users? Caching, how do we make it faster? Load balancing. Microservice design patterns. This is often what separates, say, a senior developer from an architect. Thinking about the big picture, the architecture, the trade-offs, not just the code for one feature.
So system design is key for growth. What about data structures and algorithms? DSA, still relevant for full stack with everything else to learn?
Yep, still relevant, especially for interviews, particularly at bigger tech companies. You might not be implementing complex algorithms daily, but knowing your way around arrays, strings, trees, graphs, recursion, it sharpens your problem solving. It helps you write more efficient code and think critically about performance. It's like keeping your fundamental coding muscle strong.
Builds that problem-solving muscle.
Yeah.
Makes sense. Okay, one last area. Beyond all the tech, what about soft skills? What non-technical skills are vital?
Hugely vital. Technical skills get you in the door. Soft skills help you succeed once you're inside. Communication is massive. Being able to explain a complex idea simply, that's gold. Teamwork, obviously. And general problem solving, collaborating with others to figure things out, being able to talk to non-technical people, understand requirements, explain trade-offs. That's often what makes a developer truly effective in a team. It's the glue.
The glue. I like that. Okay, so bringing this all together for you, our listener, what does this all mean? We've covered a lot today. The whole journey of becoming a Java full-stack developer, defining the role, the learning path for back-end and front-end, databases, cloud, DevOps testing, even soft skills. It's clearly a role that needs a broad understanding, a smart way to learn, and a mix of different skills.
Absolutely. And if I could leave one final piece of advice, it's this. Have a roadmap? Yes. But most importantly, build things constantly. Get your hands dirty with projects, maybe contribute to open source, and just never stop learning. Things change fast. Remember that formula we talked about?
Yeah.
Depth in the back end, but real breadth across the front end and the central tools. That's the winning approach. That's how you become truly versatile.
Depth and breadth. So as you continue on your path, maybe reflect on this. Mastering this whole spectrum, Java full stack, it doesn't just make you versatile. It really empowers you. It unlocks that potential to build almost any digital experience you can imagine. Think about that power to take an idea and build it end to end. That's all for this deep dive. We hope this gave you a solid map and maybe spark some ideas. Until next time, keep building.